Welcome to this channel. Question is, discuss the continuity of box x or greatest integer function for all x belongs to set of real numbers. To discuss the continuity of this function, first define the definition of box x or greatest integer function. This is box x or greatest integer function is equal to greatest integer less than or equals to x. For better understanding, if we take an example, suppose x is equal to 5.5, then 5.5 is equal to 5. See how? Writing some numbers 1, 2, 3, 4, 5. Left hand side also many numbers. All are less than 5.5. Less than or equals to. So, out of this integer, greatest is 5. Therefore, 5.5 within greatest integer function will be 5. Take another example. Suppose minus 5.5. Then minus 5.5 less than the integers. Consider real numbers. Real line, not real line. This is 0, 1, 2, this is 1, 3, and so on, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Before case C, 4, 5, 6. See, less than 5.5 here will be. All numbers left hand side of 5.5 less than 5.5. Out of these integers, greatest integer is 5, so that's why we have written here 5. But in this case, what should I written? See, minus 5.5 is where? Here. Is equal to minus 6. So, I think you have understood the greatest integer function. Again, now we will discuss the continuity of box x or greatest integer function. So again we define the definition of continuity. If fx be a function, or writing simply fx is function continuous at x is equal to a, if limit x tends to a, fx is equal to fa. That means limiting value of fx when x approaches to a is equal to function value at fx at x is equal to a. If function is given in the rule form, that means for less than a another function, one function and greater than another function, as we have seen here, discuss. Then we will consider limit x tends to a minus 0 means left hand limit fx, that is equal to limit x tends to a plus 0 means x approaching towards a from greater than a, fx that is equal to fa. What we have done here, limiting value of fx when x is approaching from less than a, here limiting value of fx when x approaching towards a from greater than side is equal to function value at x is equal to a. Now we will discuss about this for the case of greatest integer function, that means box x function. So case 1, Case 1. What is in this case? X belongs to set of real numbers minus set of integers. Where are these set of real numbers? And I is set of integers. So x is a not integer. So first find left hand limit. Symbolically left hand limit a minus 0 is equal to limit x tends to a minus 0 fx. Here fx is equal to box x or greatest integer function. So after putting the values, limit x tends to a minus 0 a, that is equal to, let n. A is not an integer, so n will be n less is equal to a less than n plus 1. N less than a less than n plus 1, there are two consecutive integers n and n plus 1. As for example, suppose a is equal to 2.5, then n will be 2 less than 3, and a is taken 2.5. So greatest integer less than 2.5 is 2. So now consider a plus 0 means right hand limit, that is equal to limit a plus 0 box fx means fa a n, n less is equal to a less than n plus 1. See, both cases n, because whenever a minus just less than a, greatest integer n just greater than a plus n also greatest integer is n. See, obviously, use an example. Here considering 2.5, a is equal to 2.5. This is 2, this is 3. 1, 0. 2.5 means infinite number of values, 2.5, but greatest integer function's value 2. Similarly, just less than also infinite number of values, greatest integer value is 2. So in these two cases same. So fa is equal to whatever be the value of, in this case also n. Therefore f of a minus 0 is equal to f of a plus 0 is equal to fa. So box x is continuous when x belongs to set of real number minus I. I means set of integers. Now case 2. X is a non is an integer. In this case also we will consider same left hand limit if a minus 0. Here let x is equal to a integer a minus 0 limit x tends to a minus 0 box A. What will be value of this? Suppose integer a just less than a, that means x, this is a minus 1, is approaching towards a just less than a, that is from this side. Then greatest integer from of a when x approaching towards a minus will be a minus 1, this will be a minus 1. I think you have understood this. Similarly, f of a plus 0 limit x tends to a plus 0. In this case, x approaching from right hand side, all values are greater than a, so greatest integer will be a. Obviously, here is seen that f of a minus 0 not is equal to f of a plus 0. What do you mean by that? Left hand limit not is equal to right hand limit, so limit does not exist. In this case, we need not consider function value at x is equal to a because limit does not exist. So box says greatest integer function is not continuous at x is equal to a where a is an integer. Therefore, conclusion is drawn that is continuous for all x belongs to set of real numbers minus I. So, greatest integer function is continuous for all x belongs to set of real numbers, not integer. This is the conclusion drawn. Now this is completed. If you have not subscribed, you should subscribe for getting the notification of uploaded videos. If you have any doubt, you may write in comment box. Thank you.